All right, in this video we're going to continue with solving absolute value inequalities. So example 2c, we have 2 less than the absolute value of x minus 1, which is less than or equal to 5. So here we have a compound inequality involving absolute value. So if we split this up into 2 separate inequalities, what we're saying is that 2 is less than the absolute value of x minus 1, and at the same time the absolute value of x minus 1 is less than or equal to 5. So each one of these we can turn into an equation, and we're actually going to have 2 equations for this first one and 2 equations for this second one, which means we're going to have 4 different equations we have to solve. So we have x minus 1 equals negative 2, x minus 1 equals positive 2, x minus 1 equals 5, and x minus 1 equals negative 5. Well, the good news is that each one of these are just one-step equations. You just have to add one, and we're going to get 4 different values that we're going to have to check on our number line. So we'll have negative 1, 3, 6, and negative 4. And again, make sure when you put in on a number line, you're going to go negative 4, negative 1, 3, and 6. So now we can put our test values in. Well, let's test out the values at negative 4, negative 1, 3, and 6. So if we test out negative 4, 2 is it less than, well, first, negative 4 minus 1 is negative 5. The absolute value of negative 5 is 5. So is 2 less than 5? Yes. And is 5 less than or equal to 5? Yes, it is. So close circle at negative 4. At negative 1, we get negative 1 minus 1 is negative 2. The absolute value of negative 2 is positive 2. Is 2 less than positive 2? No, it's not, so open circle at 1. Same thing with 3 and 6. A 3 will not make this inequality true because 2 will not be less than 2, but a 6 will make both inequalities true. 2 is less than 5, and 5 is less than or equal to 5. And then testing out the values, we have 1, 2, 3, 4, 5 intervals to check. The ones that make the original inequality true, which both of these parts have to be true for that to happen, are between negative 4 and negative 1 and between 3 and 6. So quite a bit of checking to do on this problem, but at least the equations part here are just one-step equations. So in interval notation, we have between negative 4 and negative 1, where we're not including negative 1, but we are including negative 4, is bracket negative 4, comma, negative 1 with parentheses. Then we're going to unite that with 3 to 6, where we are not including the 3, but we are including the 6, is parenthesis 3, and then 6 with a bracket. So here's our final answer in interval notation. From a graphing perspective, we have the first bottom red line here is 2, the top red line, horizontal line is 5, and then the absolute value graph is in blue. And so what this is saying is, where is the graph in blue, the absolute value graph, between the horizontal lines of 2 and 5? Well, it's between those two here in this region, between the negative 4 and the negative 1, and between this region here and the 3 and the 6. So visually, when you have it in between two other functions, it's where literally the graph of blue is in between the two graphs in red. All right, part D, absolute value of x plus 1 is greater than or equal to x plus 4 over 2. Let's make this an equation. So we have x plus 1 equals x plus 4 over 2, and then x plus 1 equals negative x plus 4 over 2. Well, we can clear out our fractions by multiplying the first both sides of the first equation by 2. So if we do that, we get 2 times x plus 1 is 2x plus 2 equals, when we multiply the right side by 2, it clears out the fraction, so we get x plus 4. In the second equation, we'll use the negative. We can move the negative down into the denominator and multiply both sides by negative 2. So x plus 1 times negative 2 is negative 2x minus 2. And then the negative 2, when we multiply that, this right side by negative 2, the fractions go away, and we're just left with x plus 4. So solving each one of these, subtracting x and subtracting 2. For this first one, we get 2. Subtracting x, adding 2, and dividing, we get x is negative 2. So on our number line, we have negative 2 and 2. If we test out those values in the original problem, both of them will work, and then a value less than negative 2 will make this original problem true. a value greater than 2 will make this original problem true, but nothing in between. So if we put in a 0, we'll get absolute value of 1, which is 1. Is 1 greater than or equal to 4 divided by 2 is 2? No, 1 is not greater than or equal to 2. So anything in between the -2 and 2 on our number line does not get shaded. So in interval notation, we have less than or equal to -2 is parenthesis infinity, comma -2. Oh, it should be negative infinity. I'm sorry. It should be a negative infinity there. Negative infinity, comma -2 with a bracket, and then unite that with 2, bracket 2, comma infinity. So apologize for the typo there. And once again, we have the graph in blue is our absolute value of x plus 1. The graph in red is x plus 4 over 2. So where is the graph in blue at or above the graph in red? Well, the graph in blue is at or above the graph in red for values of x that are less than or equal to -2, and also for values of x that are greater than +2 or equal to +2. So, all right, that about does it for this video. Thanks for watching, and I'll see you next time.